Hi, everyone. Welcome to our Machine Learning at the Edge panel. I'm Tina, Product Marketing Manager at Qeexo. I will be your moderator today. For our panelists, we have John, Senior Director of Tech Strategy at ARM, Chris, who is the CTO of Qeexo, Gierad, Research Engineering Manager at Apple, and Vijay from Harvard and Google. So John, say hi.
Hi everyone. Nice
John
to be
began
here.
his career as an engineer solving real-time digital signal processing and adaptive filtering problems for video and communication systems. He then went on to build specialized high-performance computing platforms using FPGAs and was an early contributor to efforts around fog computing. Currently, John works in the strategy office at ARM and makes implementing machine learning for distributed and IoT device systems easier. Chris? Chris works at the intersection of interactive technologies and AI as the co-founder and CTO of Qeexo, and an associate professor of computer science at Carnegie Mellon, where he leads the Future Interfaces Group. He has authored more than 90 peer-reviewed papers, and his work appears in more than 40 books and has been named a top 35 innovator by MIT Technology Review, a top 30 scientist by Forbes, and the World Economic Forum Young Scientist. Gierad?
Hello.
Say hi. Gierad is a research and engineering manager at Apple. His team specializes in sensing and machine learning as part of Apple's Machine Intelligence Group. He completed his PhD in human-computer interaction at Carnegie Mellon. Prior to Apple, he was a Google PhD fellow, a recipient of the Fast Company Innovation by Design Award, a Disney Imagineer, a Qualcomm Innovation Fellow, and an Adobe Research Fellow. And last but not least, Vijay. Vijay is an associate professor at Harvard. He co-chairs ML Perf Inference and is a founding member of ML Commons, a nonprofit ML organization aiming to accelerate machine learning innovations, and serves on the board of directors. His research interests include computer architecture and systems, specifically in the context of autonomous vehicles, mobile and edge computing. As of late, he has become interested in deploying machine learning in tiny ML systems. Thank you all for joining us today. Our panel topic today is machine learning at the edge. So what is your definition of machine learning at the edge, John?
To me? Okay, yeah. So I guess the first question is what is the edge? I mean, I've found that it's very different depending on who you talk to and what their use case is. And so I've generally found that. Well, sorry, an echo just appeared. Yeah, I just generally found the description of what edge is simply defined by the furthest, remotest, accessible, most manageable compute nodes that you can reach. If you have a distributed system, if you can establish a management relationship with that device, and that's probably your definition at the edge. But I would say for ML at the edge, you need to have a management relationship in such a way that you need to be able to collect data in order to train a machine learning model. Once you train that machine learning model, you need to be able to deploy it back out to the edge again. You need to measure its inference performance or how well it's doing once it's deployed. So I think once you've done all of those things, you can manage a full life cycle of a machine learning model on a remote computer with a management relationship on the boundaries of a distributed system. I would say that is what ML at the edge is. So I think a lot of people could kind of talk about ML at the edge from a use case perspective, and I'm sure we'll talk more about the use cases, but I think it helps to give a more systematic view of it, because when we start looking at solving some problems and bringing the benefits of ML at the edge, I think a systematic view helps a bit more than a use case view. So hopefully that answers the question of at least what my definition of ML at the edge is.
Sure, thank you. So why do we do machine learning at the edge? What are some benefits? Vijay?
Yeah, so why machine learning at the edge? I think the big reason that people are excited about machine learning at the edge is fundamentally because of the real-time characteristics you get. You really want to be able to perform machine learning sort of where the data resides, right? If you kind of look at how we do things today, we sort of take the data that's at the endpoint, beam it all the way up to our servers, and then really do some heavy machine learning at that in the cloud service. Now, this has worked great for the kind of applications that we've typically dealt with so far, but if you kind of look at like, what kind of things are coming down the pipe in say 5 years or so, then you really want to be close to where the sensor is, where the input is, where the analog signals are coming, and that's really where you want to perform machine learning. And the reason you want to do that is because this way you sort of really tap into all the massive amount of data that's actually out there at the endpoint, right? I think there's a really interesting stat that basically says that only about less than 1% of the raw data that's actually accessible to us is actually being turned into information, right? Now that's a remarkable stat. I mean, this really tells us that we're at the very, very beginning, right? So one is being able to tap into that massive wealth of data, which we can then translate into information. That's there. And then the second aspect is really about just that latency aspect, right? Being able to process all that data really quickly in real time right at that endpoint. I think that's the other reason. There are obviously system level benefits, which kind of get into more about like power efficiency, where everybody knows that kind of when you have communication, that's really when you're burning the most amount of power in any system. Doesn't matter if you're looking at this at the nanometer scale or you're looking at this, in a cloud to edge or endpoint sort of a perspective. I think that the other one is really about scalability, right? Machine learning as we deploy it today is not really a scalable solution. It's kind of like caught up in these little boxes. I think what we really enable machine learning at edge and endpoint, that's when you're really going to see a lot of value come out, because there are many, many use cases that we can tap into.
Yeah, thank you. Talking about use cases, Gierad, what are some practical applications that can benefit from this?
Thanks for the question. I think it's a really important one. And in my view, in my personal view, I think there's a lot of opportunity for more contextually aware applications. So, devices that know a little bit more about what's happening around them in a more privacy preserving way. And so that's where machine learning on the edge is going to be really important. And when you have that capability, you can start to imagine things that are, devices that are more assistive. They help, people get things done. You can imagine devices can be more aware of what's happening around them. So there's applications for, let's say, health that are relevant. And in that degree, you are very close to the sensor data. And if you have applications that require fast, immediate, interactive response times, having machine learning run on the edge will be really important there. And, coming from just from a personal view, you can see all these different, almost like mini ML on the edge applications that you see in phones right now, or even on watches, maybe even on AirPods, or, your smart speakers. Those have requirements that are continuously being more relevant, where, is it possible to not ship a model app into the cloud, or can we do like a language model that is just local? And you're seeing a lot of that happening, both, let's say, in the acoustic space and also in the vision space. And the more, the smaller your devices become, the more important it is to have machine learning on the edge. Not only is it working and it's accurate, but also is it power efficient, and is it, doing computation so that it enables these not only real-time interactive events, but also long-standing inferences across time. So that's just like an array of different things. But the sky is the limit if you know what your operation boundaries are.
Yeah, machine learning at the edge sounds really amazing. It has so many applications and benefits. So how do companies currently go about developing and deploying machine learning at the edge? Chris, can you take this one?
Sure. So, actually, I would say that this question is a little bit of a misnomer, because I don't think actually the complication is deploying at the edge. Like, we've actually gotten pretty good to deploying software to edge devices. I mean, in some respects, being able to deploy something like Microsoft Office across an entire enterprise fleet, like we have tools and infrastructure, and it's been a problem that's been standing, for many decades. I think the hard part is actually how you do the ML at the edge, not only in the computation, but actually in the training. Because what we see right now is the current paradigm is you train a general purpose classifier, general purpose model that might recognize, glass breaking or anomaly detection, or maybe a wake word for, let's say a smart speaker. And that has to serve all those users. So you can take that one install, that version 1.1, and deploy it to 10 million edge devices. But to really have that human level accuracy and the payoff from the applications that are going to run at that level, you need some custom tuning. You need a little bit of a tweaked model at the end, or you need to deploy different models for, kind of different applications. And we don't really see that now. We may see a little bit of calibration at end devices, at edge devices, but really they're just running a general model with maybe a couple parameter tweaks, not a custom model. And I think if we want to get to this future where we can support training and testing at edge scales, we need really good tools, and we need a paradigm shift in tools. And I really think that's the next frontier in edge ML. It's not really so much the underlying techniques. The underlying machine learning is actually pretty robust at this point. But we want to have good tools that expand the developer base and maybe increasingly draw on end users as part of that training process for that kind of last mile calibration.
Thanks. So I think this is why some people are looking into automating machine learning development for the edge devices. In fact, this is what Qeexo does. So do people believe that machine learning should be automated? What do you think, Gierad?
So I think I can come from, my personal view there is, first, let's define what automation is in this case, because also machine learning is a pretty broad term. So what are we trying to automate, right? Are we trying to automate the learning process? Are we trying to automate the deployment? Are we trying to automate the tuning? It's still, a little bit too broad of a question, but I feel like we could start there. Like, what are we trying to automate? Because some aspects of the pipeline, yeah, I can see it being automated, but there are some aspects of it that are probably like, it doesn't make sense to automate it because, again, it might be too, the end application may be too constrained, or maybe it's just too hard of a problem to automate. So I guess, to open the floor up for discussion, let's try to figure out, okay, which aspects of the pipeline are we trying to automate? And we can debate on whether it makes sense or not, at least from my personal view.
Yeah, so what do people think? What should we be automating in machine learning for the edge? Chris, do you have an opinion?
Go for it, John.
Or John, you want to say something?
Yeah, I was going to step in. I do think, just to push on Chris a little bit, when you said, the problem's not in the deployment. And I do agree with your point. Deployment out to devices has been done for a long time, but the smaller the device gets and the more you move away from Raspberry to Pi-like devices, and once you can't rely on containers and robust Linuxy-like management relationships, then it becomes harder to manage them. So I do think the automation in order to create a cloud native development experience is needed on these devices that don't look and feel like a Raspberry Pi, basically the embedded devices. Once you take that away and it feels a bit more familiar to a regular developer, then I think things will start moving quicker. So I think some automation and a whole bunch of work there needs to be done. It's not as glamorous as the AutoML, of course, but I think you'll benefit greatly if it's in place.
Yeah, I didn't mean to disparage all the incredible work that's happened in there, and it's definitely not a solved problem. So I agree with you that it's still an important pillar that we need to make progress on, especially as the devices get increasingly small, as you're alluding to, right? Like as they really shrink down to, basically just a firmware, not even like a real-time operating system, then you really have to be incredibly lean and careful about what you deploy. To bounce back to Tina's question, or I guess, and Gierad's answer about automation, I agree with you. Automation is this big term. I think that we should try to automate as much as possible. And in fact, machine learning has automated a lot. And a lot of the really tedious data tasks are all automated. And the whole notion of training a machine learning model is essentially automation. But I do feel like we're not quite at this stage where it can be fully automated. There is sort of a degree of ML craftsmanship that still remains, and you need experts. And I think there's also humans in the loop let you apply some ethics to the machine learning, and we know there's lots of horror stories there as well. But the other good thing about automation on the flip side, and why I'm still a supporter of it, is we want to draw more people in. We want to expand the user base. Machine learning is such a powerful thing. We want to expose that to more and more people, and automation is going to make that easier and easier, and improve adoption.
Yeah, thank you. Does anyone have anything else to add? It's a pretty broad and complicated question, I think.
I think the one thing to add would certainly be that we often, when we talk about machine learning, we often focus on the training. And when we talk about training, we pretend like this magical data set just simply exists. When in fact, we all know that that is the one that you really got to spend your cycles on. And that's where most of the effort is going in, right? Now, if you kind of look at the ecosystem, I would say that the big companies have this thing nailed down. They have the bandwidth, they have the capacity to be able to do this. So the question is, like, if ML is to be at the edge, which means there are a lot of small companies that are probably going to want to play in the space where you can really drive an ecosystem forward. Then the question becomes, like, how do you make that data collection process something that is actually accessible to everybody? Not everybody should be inventing their own little silos and do kind of like, okay, well, I'm going to go get my data through some sort of, I'm going to build my whole vertical pipeline in order to get to the training part, right? Because we all know it's garbage in, garbage out. So it's really about the data. I think that's often very much overlooked, even though when you talk to the people, they will say, like, that is one of the critical things that we spend most of our money and time on. And I think democratizing that data engineering pipeline is going to be super key for the next 2-3 years. I think if there's one thing I would place my bet on, I wouldn't be worried about, can we build a machine learning hardware? Can we build a machine learning software systems? Can we shrink all of that down? We will do it. You give that problem to an engineer, they will crack it. What we got to really spend time thinking about is, how do we craft what we are not often talking about, is that data pipeline. And how do you make that time to solution extremely small? I think that's one of the key things, at least I think, that needs to happen.
Yeah, I would agree with that too. Just generally see that there's as much effort in picking up the ETL pipeline that feeds the machine learning, and getting that ETL pipeline working in an embedded footprint is as challenging as solving some of the ML problems, and sometimes more resource consumptive too. So it can take a lot of cycles to do that.
Yeah, I just wanted to add too that there is a validation component too. So are we going to automate that? Like, if you have an updated model and you have an existing model that is deployed in the wild, like, how do you know that your new model is not going to, like, do something weird with, things that are already out there, right? That's like, that piece also needs to happen. Like, what is the validation scheme if we are to automate this component? Yeah, but overall, I agree with folks that there are aspects of this that can add a lot more value if we automate it. But I do feel like it's not wholesale, or you're not going to get everything for free automated. There is still, I truly believe, some level of human input that needs to happen to make sure that things are safe, things are privacy preserving, and things are valid and accurate.
Yeah, thank you. I think automation might be a field where we have a ways to go for machine learning at the edge. What about industry best practices, standards, and benchmarks? How do they help to accelerate machine learning innovations? Vijay, I know you've done some work in this area.
Yeah, talking about industry standardization for machine learning, yeah, you can wake me up anytime in the middle of the night and I'll be happy to talk about it. So I think if you want to move the industry forward in this space, right? I think Chris or Gierad, John mentioned earlier that you need to get the tooling and all of that ecosystem together. Now, really, if you want to move the ecosystem, there are 4 people or 4 groups you really got to help. The first is the application developer. The application developer, when you're talking about things at the edge, often ends up wanting to understand, well, what is the system capable of? Because I want to be able to deploy the machine learning, and I need to understand that system. This goes back to the point that, like, in traditional bigger systems, right, you typically don't worry about what the underlying system capabilities are as much, especially in the inference case. So, but today in the embedded kind of space, the developer has to understand this quite a bit. Then you go down to the device manufacturer. The device manufacturer, someone who's trying to package up the board, will need to do a lot of homework in understanding what the microcontroller stack is going to look like, what the software stack that goes on it. They will actually spend an insane amount of time trying to do this coupling very carefully. And they've got to do this extremely meanly and efficiently because it's costly, right? And this ecosystem does not tolerate any high cost. And then the one below it is the framework developers, folks like the TensorFlow team or like the SDM-Cube AI or TBM. These folks are building these runtime frameworks. Now, because the underlying microarchitecture is so heterogeneous in terms of the types of MCUs they have and how confined and constrained they are, they have to do pretty careful tuning and optimization manually in order to get the maximum performance from the hardware. So it becomes a real problem for them. So they're spending a lot of time. Then, of course, you have the silicon folks, like people like ARM, who actually have the hardware, but they're like, well, what's the use case? So if you want to move this entire, all four groups forward, because that's when you will really unlock the capabilities of, deploying ML at the edge, then you've got to figure out how you're going to enable that, right? So you got to have metrics, things that people will agree on as to what is a standard benchmark, and agree on what the machine learning task is, how you do the pre-processing, when do you do the timing, what are the models you're putting in there, the data sets you're using. So all of these are things like, for instance, MLPerf, which is a machine learning benchmark that has been created about 2 years ago. It's an effort that I'm deeply involved in. That's helped kind of provide a common yardstick for everybody. So we need those kinds of big industry community-driven benchmarks, not a benchmark that someone kind of builds and throws overboard, because I don't think that makes any sense. It's got to be a community-driven effort, because this space is super heterogeneous. So unless you can bring people together, we won't end up with a standard industry benchmark. But once we have an industry benchmark, I think that certainly helps. And then I think we also need systematic frameworks, right? A common framework in an extremely heterogeneous environment is super critical. So I think the ecosystem is still very wild in the embedded space, at least. I'm talking specifically about inference-related things. That needs to be somehow abstracted up to some level. I think those are like two big infrastructure/tooling things that need to happen to move all four groups forward.
Hey, just a question. Do you think, you think we should try to get our heads together and work on some kind of definition of device can be used as described for an auto
Yeah, I think there'd certainly be a lot of interest to do that, right? One of the things we're actually doing in the extreme small space, which you mentioned, John, earlier, was like in the tiny amount space. We've been bringing the industry together to write out what a standard benchmark would look like, for instance. That's just one sort of effort that we're seeing where there's huge amount of interest. Any sort of general standardization efforts, I think, would really help us move forward. Typically, when I see a standard, I kind of balk because I'm like, oh, it's a standard. This is just going to slow things down. But I think in this one particular place, in this domain, I think standardization will actually help us achieve something much more than if we don't have it.
Yeah, just a common way of saying, hi, I'm a remote edge device and I'm capable of doing this type of ML, or I'm capable of, I have this amount of linear algebra performance available to you, so do what you will. But it has to be described in an automated way and fed up the stack.
I'm seeing that your question, when you asked the question earlier, John, there was some feedback on the computer, so we may have to re-record your question part, if that's okay.
Yeah, I noticed the feedback, so I'm not sure where it came from, but hopefully it wasn't too distracting.
Okay, maybe we can do that later. Yeah, so that's all very interesting. I never really thought about standardization of machine learning until Vijay. Thank you. So it sounds like the technology is real and here to stay. So machine learning at the edge will continue to grow exponentially. So where is the money? What opportunities do you see in the industry? John, care to share your thoughts?
Yeah, I guess you always have to answer that question with, well, I guess that's the billion-dollar question. So, I mean, there seems to be a healthy space of use cases and problems to tackle. So it seems to me there's opportunity everywhere. And I suppose it's like most emerging kind of tech spaces, that layers and, niches will emerge. So I guess, working top down, starting with the use case. I mean, I just generally see that aligning to the specifics of the use case extracts more value. But underneath that, empowering the people to do so, underneath that, there's a lot of opportunity. We've talked a lot about this on the panel, actually, around the words of tooling. There's a lot of opportunity in tooling and technology that just takes domain experts, people who know the problem they want to solve, whether it's an electricity expert, distribution expert who understands how their synchrophasers should be behaving. So empowering people like that to be able to express their edge ML problems in a way that's implementable requires a lot of technology underneath it. So it feels like, the opportunity space is something to do with the fact that we're assuming that data scientists and applied ML engineers will just magically become distributed systems and embedded engineers and vice versa. And their jobs are hard enough already. So I think there's just a lot of opportunity to help them. So we've talked about this. I mean, it's tools that help manage, deploy edge ML models, in that cloud native kind of way. Tools that enable collaboration across separate work streams, even just getting, the work streams of data and ETL and applied ML and data science and distributed and embedded systems engineering combined. That needs some work there. I mean, AutoML has come up a number of times in this. I think AutoML is really important. It's a very hard problem, as has already been mentioned, to ask somebody to say, give us 90% accuracy in recognizing this particular event. But, oh, by the way, you can only do that within 500 kilobytes and 500 milliwatts of thermal envelope. That's a very, very hard thing to go and do. So anything that helps there is a big opportunity, I think, particularly if you can empower non-experts to make some progress. And I think as an opportunity space, we've seen that the enterprise world has taken some strides in this. There's been a whole bunch of companies that have emerged in the cloud world who've helped automate ML. And so why wouldn't we see the same thing at the edge, where the problem is just much, much harder? Other opportunities, I made a note of this one actually because I thought it might be interesting to chuck into the panel. Perhaps the emergence of ML model markets. So, I mean, all new emerging spaces seem to bring around the idea that there'll be a marketplace or something. So why not ML model markets? I don't know if it's possible, but it could be a thing. And then, of course, speaking on behalf of ARM, where I work, it's like devices. I mean, there's a huge opportunity. It's like the only reason that anybody would want to put a device out in the field is to do something intelligent. And so once you can solve the ML problem, we ship more devices. And, the way that we count things in ARM, we're expecting to see edge computing and endpoint intelligent devices counted in the trillions. So it's an enormous opportunity for that from that perspective. And so for all of those things, there's these different stacks from low-level tools all the way up to like solving discrete use cases. So I guess it's a rich theme to go and mind, and it remains to be seen where the actual dollars will shake out. So yeah, they'll shake out somewhere, but they're there.
Thank you, John. It looks like we're almost out of time. So last question. What do people see in the future for machine learning at the edge? I'm going to give this to Chris first.
So, I mean, people have already mentioned a few times that tools is really going to be central to the future of edge ML. And obviously, we have small computers that are everywhere now, right? All your kitchen appliances, your laundry machine, your HVAC, your garage door opener, the list goes on and on. And I think that means that in the very near future that all those will be edge devices too. And some of them already are becoming that kind of category now. And the problem is that the paradigm we have, even though they may be internet connected, is that they're all essentially being programmed with a series of heuristics. And, really edge ML is this magical pixie dust that we can go around and sprinkle on all these devices to make them much more kind of useful and intuitive and context aware. I often bring up the example of the internet connected, toaster, and, people, poke fun of it all the time. It's essentially a meme in the IoT community. And I think actually people miss that people, like consumers, might actually not mind an internet connected, machine learning powered toaster if it made better toast. And funnily enough, the kind of internet connected toasters that are out there right now don't make better toast. They're just like voice enabled. They miss the point of the toaster. So I think there's a bit of kind of alignment to be done. But I do think the demand, is really out there. I think, ARM has already showed the industrial value of sort of edge IoT. But I think that's coming in the consumer space too, if we can really deliver, value for people. But in order for that to happen, we really desperately need better tools that reduces, the barrier to entry to that space and really automate some of the key tasks that we alluded to earlier. Companies that make a consumer device, a KitchenAid and toaster and a blender, they don't have machine learning teams, and in order to make those products smarter, they need either help from other companies, or better yet, the tools that kind of expose the incredible power of machine learning to their engineering teams. And their engineering teams are often very capable; they're just not ML engineers. And so that's why I really do feel like tools is a real key to the future.
Thanks, Chris. Anyone else? What's in the future?
So what gets me excited is this idea that machine learning can become almost like a material for designing new experiences. And so right now, machine learning is in the hands of, let's say, mostly engineers, maybe some product people. But if you give this to, people who dream up about new experiences, that could be, everyone in the stack in the product group, whether that's designers or everyone, just to have the vocabulary to talk about it, to know the limits of what that material can do. Just kind of like when you're designing something in the industrial design space, you need to know what the materials are and what the limits are. It's the same with machine learning. And once people start to understand that, I'm excited on a future where we get more magical experiences, just because we've crossed the envelope of what it means to use it as a tool, not as a hammer for like everything else, but like as a kind of like an artisanal tool in your repertoire that you can use or you choose not to use, but you know it and it's there and you can enable these magical experiences. So I'm excited about that, and I'm hoping to see progress in computing and progress in ML models and progress in efficiency all move that vision forward. So that's looking forward to that future.
Thank you, panelists, for your time and expertise today. I'm really excited to see what you guys will come up with in the future for machine learning at the edge. Thank you.
Thank you very much.
Thanks, all.